Everybody, this is Pete from PA Labs. I had a thought last night, and I want to make sure everybody's on the same page. So today, I know I'm in the middle of one series of videos. I just started one, and I'm going to start a second one. So this is going to be Pure Basics, a learning series. And it dawned on me that we as developers pass around lots of words and phrases that everybody knows or they think they know or understand. Terms, terms like the enumerators, objects, a reference to an object, or passing a reference to an object, or pointers, trying to understand the difference in the pure basic syntax of when do you use an at sign and when do you use a star and what all that really means. I made it my first series that I did on Class Builder. I made an assumption, and that's never good. And the assumption was that everybody's kind of on the same level playing field, but in all reality, I mean, you got brand new people, you got seasoned people. So what I want to do is do a few lectures, videos on this learning series concept. And I'm going to start with my project of parent-child. And I'm just using it as an example because it's got all the components that I've referenced in the beginning of this. So if you look at constants project sheet, here, the parent-child constants, this is what's generated from the ICE design process where it brings all of your form uh, enumerators together and then builds them all out on this sheet. So this is a good starting place. It's the enumerators. Everybody understands that an enumerator is an ID. Basically, that's correct. It's just an ID. It's a name for a piece, what's going to be a piece of your memory on your computer. So PureBasic has a number of categories of these enumerators, and obviously you can't have two pointers to the same piece of memory thinking that they're different. So let's come in and say, okay, form windows, that's one of the big categories. Gadgets is another of the big categories. And then we have, let's see, we have images and fonts. Those are like the four big categories, and each of those are basically independent lists of numbers that can start at one, you don't want to start at zero. Zero has a definition of nothing. So you always want to start your enumerators off. I do. Personally, it makes logical sense to me at one, but I know you can start them at zero. But let's look at like FRM main. So here is FRM main. It's going to be a window enumerator. And if I jump over here to Windows, and let's go ahead and collapse this code so I can just look at my definition of the window. We're going to open a window and we're going to issue it this ID. So this is an ID. By definition, it's going to point to a specific place in memory. The window will live as you define it. So when this line of code, when the thread of code crosses this line, he will create a block of memory. He will partition it aside and assign window FRM main to point at that, and that becomes your window sitting literally in memory. So as he comes down this page here, he does the same thing for text gadget, for the font, for the list icon, for all the individual gadgets that you create. All of these enumerators that you have here are pointing to a specific cell in memory that is partitioned to be that physical object that you are creating. When one of these enumerators gets created in memory, then it's referred to as an object. It physically exists, okay? It has been defined. It has the definition is normally referred to as a class, and when an object is created, it becomes an object. When a class is instantiated or brought into the real world, it then is an object. So each of these, as this runs, becomes objects for you. And it's no different than when you define a module. So a module, and this is one of the reasons I love modules in this system, a module is a class that I am creating. I can make it look like anything I want it to look like. And when I define a variable to be the class, then at that point, it creates the object in memory, and my definition variable becomes the pointer to that spot in memory that physically is my sprite sheet. Okay? So you can come in objects and define the actual fields. You can create collections. Here's a really cool aspect and thought to put in your head, that when you create a list in your object, then what you're actually doing is creating a list of additional objects. As you load the children, those individually have their own variable. I mean, it is a SS tile collection list. Each instance of that list, each record in that list is itself an object that is specifically mapped to a point in memory where that specific object lives. Okay? So where people get in trouble with objects and you end up with what's called a memory leak is where you do this code generation of an object inside a loop, and you can real fast create thousands. If you don't delete them and don't dispose of them, they stay in memory orphaned from your code until the disaster happens where the memory fills up and your program crashes. So if we come down here, you will see that we have an initialization step and we have a dispose step. So we have a way to delete these objects that have become created. We have to have a way to delete them out of memory and reclaim that memory for your program. And a lot of people get in trouble, and I do too. You forget, you accidentally leave off a star, and I'll get to those in a minute, an asterisk, and you create the objects instead of reference them. And boom, all of a sudden, before you know it, you've got a big memory leak. The same thing with images. Images is another problem, and it's the same problem. When you create an image, it blocks off the memory on your hard drive, or not your hard drive, the memory in the computer, the RAM. It blocks off an area for the image, and it puts it in memory as a binary image. Now, if you don't free the image, it stays there. You can orphan it, you can create it, put it in a loop and create it 80 times or 1,000 times, and you just blocked off a huge section of your hard drive or your memory on your computer with this one image. So it's always important to be cognizant of when a class becomes an object and is in the real world, to make sure we delete them and clean them up. So if you'll notice in my initialization step, the first thing he does is called dispose. So you're passing me a reference to a variable that should be created as a definition of the sprite sheet class. And the first thing I do is make sure if it already existed, I kill it in memory, and then I regenerate that creation as defining what he is and initializing all the values. And that's a very important thing. So here's an example of a find. We're finding based on a sprite sheet ID, and the asterisk here says, I want a pointer. You can't pass me the physical object because that's just massive. A pointer is the ID, the location in memory where this object exists that you want me to load. So that's a single ID. That's just a big integer. Okay. So we call the find here, and we pass it the ID that we want to find, and that's one of the primaries, so you don't have to mess with references. They just are a thing. So my modules and their instantiated objects, we have to pass a reference. We have to pass the pointer to the memory that is the sprite sheet you want to play with. And you do that by passing, if I come over, pretend this is another area and have a definition somewhere, DEF, define my sprite sheet as, let's see, sprite, oh, it's not going to let me do it in here, is it? SPRITES, sprite sheet. So at this point, I have defined sprite sheet. So at this point, I have created this object of this type, okay? So now you are pointing, the minute this code runs, this is pointing to a specific memory location of what is going to be a sprite sheet. So all of that memory needed for the sprite sheet is allocated. Now, when I pass that to find, I come over and say, okay, we come over and then we are passing, let's see, sprite sheet. So we have sprite sheets, find, and I want to find ID 1. Now I want to pass it the reference to my SS. So that's where this comes in. So now I say my SS, and now what he's done is when this executes, I have my definition. He points specifically to a spot in memory. That memory spot is what is passed here. So when this function receives it, he has a handle. He has the location of memory where that object exists in your RAM. And now we come down here and we initialize that spot. We're going to clean it all out. We're going to wipe it away. We're going to reuse it because initialization does a dispose and then a reinitialize. And then we come down here and we then load the actual class here. With the class, we populate all its fields. So that is what's happening in these modules, and that's why they're so powerful, and that's why they're so awesome.